So hello, I'd like to welcome you to this manufacturer showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with new or emerging technologies meant to facilitate decarbonizing our building stock and applicable across entire portfolios. All sessions will be recorded and available upon request, and slide decks will be sent to all attendees. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to questions you post in the chat. We ask that you mute yourself at this point to prevent any background noise. And now it is my pleasure to introduce David Goldstein, CEO of Hydronic Shell. David?
Yes, hi everyone. Looking forward to telling you all about Hydronic Shell today. I just want to start by saying how excited I am, how thrilled I am to be a part of this EBC cohort. Really looking forward to getting to know everyone else, collaborating, learning from you guys, and also excited for the opportunity today to share the work that we're doing with all of you. So before I jump into it, I do want to just acknowledge where all the funding has come from for the work that we're doing over the last few years. Enterprise Community Partners, Wells Fargo, the Department of Energy, Syracuse University Center of Excellence, the JLL Foundation, and Oak Ridge National Lab. So we're really excited about this project, this pilot project that we have planned as part of the Empire Building Challenge. This is a building in Syracuse, New York. It is affordable housing for elderly and disabled residents, built in 1954, 7 stories tall, 54 apartments. Construction, we're planning to begin in the second half of 2025. And you know, Hydronic Shell is just a small piece of a much bigger team. We really have an incredible team on this project with Cycle Retrotech. It's the Syracuse Housing Authority that owns and operates this building, Tatum Engineering, Block Power, and Syracuse University. I'll talk a little bit more about the project towards the end of the presentation. So I want to start this kind of the beginning of the story, how this all came to be. So my career as an HVAC engineer began in 2007, working in New York City. And I really didn't get my first exposure to public housing, affordable housing, until around 2019, which is when I got involved with this NYCHA project, the New York City Housing Authority, to do a heat pump retrofit pilot at Fort Independence. To make a long story short, this was a really eye-opening experience for me. And there were a few really big takeaways from this project that I would like to highlight. The first is what a huge challenge tenant disruption is when it comes to doing these retrofits. Second is how challenging the economics is. Just because electricity is so much more expensive than gas, even if you're replacing a boiler with a very efficient heat pump, it's still very hard to get a good return on investment. In many cases, operating expenses even go up. Another challenge that I became aware of is just how much this goes beyond decarbonization, and indoor air quality is such a huge problem in these buildings. It really has detrimental impact on the health of the people who live in these buildings, and it's another issue that has to be addressed. And so the big picture takeaway for me from this experience was this whole idea of getting to net zero by 2050 just would not be attainable without some major innovations. And so, you know, as an HVAC engineer looking at this problem, I want to kind of share the way I viewed it and kind of what came out of the research and the analysis that I had been doing. And I think it's helpful to look at HVAC systems and split them into 3 categories: unitary approaches, which is, you know, kind of through the window, through the wall heat pumps; central approaches; and then hybrid approaches, which would be like a central system sort of, but on an apartment by apartment basis. And so I want to just quickly go through, kind of simplify it a bit, but the top 3 pros and cons of each of these options. So unitary HVAC, low installation cost, it's non-invasive, and it's not complex. Those are the obvious advantages. But some of the disadvantages are that it's poor efficiency, which, you know, if we're trying to do efficient electrification, is a problem and leads to high operating costs. It's ineffective for providing ventilation, and it creates a big maintenance burden for the building owner who is now responsible for maintaining these units in every single room of the building. If we look at the other end of the spectrum with central HVAC, there's a lot of advantages. You're now dealing with commercial grade equipment, better efficiency, more reliable. You have a lot more flexibility in the way you design your system. You can incorporate things like heat recovery, thermal storage, connecting to geothermal networks or district thermal networks. And from a maintenance perspective, your maintenance is centralized. So you're not doing all this maintenance within the apartments. But there are obvious cons to this. It's high installation costs, it's invasive, and it's just a more complex system. Now, when we look at the hybrid approach, and this is like, for example, mini splits with a little ERV in each apartment for ventilation, it's good efficiency. It can provide good ventilation, and the complexity is not as much as a fully central system. But you kind of get the worst of both worlds. On the con side, it becomes a high installation cost. It's still very invasive, and you still have this huge maintenance burden of all these little pieces of equipment that you have to maintain in every apartment. So while I was going through this thought process as an HVAC engineer, I was also recognizing from that pilot project that really when you're dealing with a poorly insulated or uninsulated leaky building, you really have to address the envelope as well. You need to bring the loads down, which reduces your heat pump size, helps to avoid electrical upgrades, and is what ultimately reduces your operating costs so you can actually get a return on investment. And I was looking at what was happening on the facade side with these panelized overclads using modular prefabricated panels as a way to avoid tenant disruption, a way to really do it non-invasively and at scale. And so, I got to thinking, I loved all the advantages of the central HVAC system, and I wondered if we could kind of take a similar approach to avoid the cons typically associated with a central system. If we could take that central system and pull it out of the building and incorporate it into the facade so that we can get those same advantages. And so that's ultimately how Hydronic Shell came to be. And so I'll share with you what this looks like. So if we look at one of these existing buildings, what we're doing is we're putting new central equipment up on the roof, air to water heat pumps and packaged ventilation units, sending the hot water and chilled water risers, as well as ventilation air and exhaust air risers down the facade of the building between the windows. And all of that distribution is within a new overclad facade, much like I showed you earlier. So this concept of doing duct and pipe distribution within an overclad facade is actually not totally new. These are two examples. On the left is a project in Brooklyn, and on the right is a project in Massachusetts where they're doing this. And they've done it in Brooklyn. That's complete. So it can be done. And what we're doing is slightly different, though, and has some advantages, because ultimately the way they do it on these projects, they run the distribution down the facade, but then they still have to penetrate the facade and distribute to internal units within the space. And so what's really unique about what we're doing is we're integrating a terminal unit called the Hydrobox into that overclad facade panel. So that Hydrobox is connecting to the water piping on one side to the ventilation air on the other side. And then you can see from the image on the right how it sits between the existing facade and the new facade to deliver that conditioning into the space without any components actually required in the space. And if you look at what this Hydrobox is, it's actually a pretty simple unit. It's taking return air through that top grill, running it over a coil, and then a small fan array pushes it back into the room again through the top grill. Everything happens through the top grill, all the airflow and all the maintenance. So if you need to access any components, you do it through the top grill. If you need to replace this unit, you remove the grill, slide the Hydrobox out, and slide a new one in. Another interesting thing we're doing is we're providing this conditioned ventilation air to the Hydrobox, and we're also supplying a little bit of it into the cavity. So we're actually conditioning the cavity itself with dehumidified air. And so that does a couple of important things for us. It allows us to do the duct and pipe without insulation. And then the other thing it does is it avoids moisture risks within that cavity, because that's one of the big risks with overclad facades, is that you can trap moisture behind that overclad and run into some really serious problems, like with mold growth, for example. And then another interesting feature we have is to actually add a convector below the hydro box. So now we're actually heating that entire facade cavity, creating what we like to call a heated blanket effect around the building. So we're turning that existing masonry into a radiant wall. And one of the really interesting things about that is we're actually storing heat in that masonry. So for peak load reduction, for demand response, you just turn the system off, and then that heat will just continue to radiate from that massive masonry wall for an extended period. So a few key benefits of this to point out. One is we're operating with very low hot water temperatures, 95-degree hot water, probably even lower than that, which means the heat pumps can operate very efficiently, even in a very cold climate. Because we're doing the ventilation air separately to provide dehumidification, we're decoupling the sensible and latent cooling for the space. And so that makes the system, from a cooling perspective, more comfortable and more efficient. And it also means that there's no condensate. We're not producing any condensate in this hydro box, which means we don't have to worry about disposing of that condensate. And then the last point here is that that hydro box is very low power. It's essentially the power of a light bulb just to spin those little fans. And so it can be powered with low voltage distribution, 24-volt DC power that we will also integrate within the facade. So it's going to be all new power distribution within the facade, doesn't need a licensed electrician to install it. And what that does is it actually frees up electrical load on your apartment panel, because you're no longer powering window ACs. So you now have spare capacity available to electrify other appliances. It's kind of a no-brainer that this is going to save a lot of energy because we're super insulating the building, and then on top of that, putting on a super efficient HVAC system. So you get major emissions reductions, energy cost savings, and even though we're electrifying the building, we still reduce the peak demand of the building. There's obviously challenges that come along this as well. So just to highlight a few, there's things you have to do to comply with fire code. For example, fire stopping at the floor lines and vertical fire stopping need to pass various testing requirements such as NFPA 285 for fire safety. We need to ensure that we're allowing access to the ducts and pipes behind the facade. We need to design an anchoring system that really allows for suitable tolerances when you're installing an exterior system on a building, because an existing building is not perfectly straight, and we need to be able to accommodate all that variation on the existing building. Another challenge is minimizing the overall depth of this. So our maximum depth that we're targeting right now is 12 inches, because as you get deeper, it can become more difficult to incorporate, and you can run into code issues as well. And then lastly, just optimizing the sequence of installation for a system like this. So this is a pretty new concept. How do you actually install the facade, make the connections between the duct and the pipe, all that sort of thing. So I'm going to show just a quick example installation sequence here. We're working on several different potential sequences, but one here is installing the duct and pipe risers, then installing these window panels with the hydro boxes between the risers. And now you have easy access to connect from the risers to the hydro box. You can do that from the exterior, and then having your set of infill panels that get installed to complete that exterior shell. I want to talk a little bit about the central equipment, shown here with packaged rooftop equipment, air to water heat pumps, but it's actually flexible for what the central equipment will be. It doesn't have to be on the roof, and you can, it can be located elsewhere, and you can do things like connecting to a geothermal system or to a district thermal system. And so this is a view of the neighborhood that our pilot project is in. That's our building 418 Fabius Street in Syracuse. And this entire community you see here is owned and operated by the Syracuse Housing Authority. So you can imagine in a situation like this, where you can have a district thermal system distributing heating and cooling throughout the streets to every building, and how you can get huge efficiencies out of that. And not only are there huge efficiencies operationally, but from a cost perspective, it becomes really interesting, because now it's not necessarily the building owner that's paying for this. This is something that the utility can provide. So it can actually take a lot of that installation cost off of the building owner and onto the utility. And this is what utilities do. They build infrastructure. So it's actually a really good alignment of interests. And it's something that we're certainly exploring for the pilot project, at least to incorporate into the future to connect to a district thermal network. I do want to talk about cost a bit, because that's a perception of central systems, is that they're more expensive, and in many cases they are. But when we do it in the way we're showing here, in this example, this is looking at a wing of the building with 24 apartments. And the total installed cost for this HVAC system would be about $470,000. But that's for 24 apartments. And so when you amortize that over each apartment, it's actually less than $20,000 per apartment. And we think we can drive that down further. And when you start incorporating, incentives into that and everything, you can really see extremely attractive costs for this kind of system, especially when you consider it's a super efficient heating and cooling system plus ventilation, outside air, exhaust air, energy recovery, all that. It can be extremely attractive from a cost perspective. Really, the biggest cost driver on these projects will be the facade. I mentioned that on these old uninsulated leaky buildings, upgrading the facade is a must. And it's something that the industry has to do to really drive down the cost of these facade upgrades, especially as we start getting economies of scale. And that's one of the things our team is really working on, is how do we reduce these costs? And there's many different elements of that, but one is how these projects actually get procured and delivered. And so our model is that we deliver them as a turnkey solution. You have one solution provider. In our case, that's Cycle Retrotech, who pulls all the pieces together to deliver this to the building owner. And as you can see, Hydronic Shell is a small piece of that. We're essentially providing the hydro box. We're partnering with facade manufacturers to create this integrated facade panel. All the other pieces have to come together to deliver it on the project. I have about 3 minutes left, so I'm just wrapping up here. Just to talk about the types of buildings this works for, because it's not the right solution for all buildings. It's good for buildings like you see in this image here, which all of us in New York are very familiar with. So, probably for very small buildings, it doesn't make sense. So, 10 plus units, you want this kind of robust concrete masonry construction, regular pattern of punched windows, simple geometry, flat roofs with space for equipment. And ideally, you want to have clearance, all around the building in order to wrap a new shell around it. There are lots of typologies that are challenging. For example, if you have the historic facade that you don't want to cover up, that's obviously a concern. If you have complex geometries like on the top right there, it's difficult to coordinate the overclad and the duct and pipe risers running over all that complex geometry, so that can be a problem. If you have highly glazed facades, there's not really space to run the duct and pipe risers. We can accommodate a bit of balconies, but if you have a building that's like covered in balconies, then that can be an issue. And then there's also just code, regulatory restrictions that have to be considered. Could be zoning restrictions or things like that related to increasing the volume of the building. So just want to talk a little bit about our actual project. So up until now, the HVAC development has kind of happened separately from the facade piece of it. And so what's going to happen in between now and September, what really started back in January, was the integration. So taking the HVAC, choosing the facade system that we want to use and integrating them together, and working out all those details of integration, and then testing, getting the certification for that integrated product. And then the actual design for this project will begin in around March of 2025. We're looking at construction roughly August 2025. And then we'll be doing performance monitoring for a year to gather all the performance data. And that's really it. Once again, thank you so much. I apologize that I went through that very quickly, but I wanted to try to squeeze as much as I could. Really happy to have a bit of discussion now. I think we have 10 minutes for Q&A. And I think we have other members of the Empire Building Challenge team here. So, as questions come up, if anyone else from our team wants to jump in, please feel free.
Great. Thank you so much, David. I had said post questions in the chat, but I think if you just want to unmute yourself, that will be easier. So, yeah, if anyone has any questions, please feel free to unmute and ask.
I'm happy to go first. I'm Loic Chapeau, I'm a senior advisor with NYSERDA. Thanks, David. That was really good presentation. You're describing your system going under a new facade, right? Insulated facade. Is there kind of a minimum R value that you need in that insulated facade for your system to function properly?
Yeah, so that's a really good question. Yes. So obviously with any retrofit, you want a high R value to prevent heat loss, from the building to make it more efficient. But from in our case with this type of system, it becomes even more important because we are running the ducts and pipes down the facade. And especially if we're going to heat that cavity to create, that heated blanket effect, we want that heat going into the building, as opposed to outside of the building. So it does become very important. We're targeting R25. We'd love to do higher R value, but we think R25 is a good balance. We are limited by overall depth of the system, so we can't just go with a really thick panel for a really high R value. We're limited by weight of the system as well and cost. So it's really about finding the right balance, which for us is roughly R25. But even for this project specifically, it might not be exactly that. We have to see what comes out to be the ideal value. Potentially, it could be a little less than R25.
Thank you.
Great. Any other questions?
Yeah, hi, David. Thanks for the presentation. But how do you deal with the bricks when it comes to local law 11 that you're covering?
Yeah, so that's a great point.
David, I can take that if you like.
Yes, please do.
Yeah. So, if you have a building that is 6 stories or more, this is Tony Daniels, by the way. I'm calling in. I was out in the field. So the Cycle Retrotech, who David mentioned, is Hydronic Shell's implementation partner on this project. The requirement to inspect doesn't go away. But what you're inspecting does, you don't have to inspect, the brick which is concealed behind the facade, as a part of the regular inspection cycle. So what you need to account for is during the initial design, you've got to make sure that you're going into structurally sound substrate. And
Tony, I'm sorry, the siren is drowning you out. Maybe we can come back to this when you have a little more.
I hope he's not riding in that ambulance.
Yeah.
No, guys,
Is he okay?
well, thanks to I'm okay. Thanks to the Doppler effect that the siren is gone and I can continue. I just have no idea what's making it into the microphone. But you have to make certain at the initial installation that the substrates are sound and that they're in a good state of repair. That's something we do at the outset of the job. But then afterwards, once the building is up, you still have to inspect. But the kind of inspection you do is a lot less time-consuming or rigorous. I mean, you're primarily looking at sealing and joints, rather than inspecting every brick and lintel and doing repointing and all of that. So long term, much less maintenance on a panelized system than.
So would you be required to remove panels to inspect?
Why?
I don't know. I'm just asking.
Do you ever inspect the interior of a building when you?
No.
I mean, it's I guess
facade would now become the exterior of the building, and it would still be subject to local law 11 requirements, but you would now be inspecting the exterior of the new facade, not the previous masonry or the existing masonry that's now been overclad. Correct, Tony?
That's a good way of putting it, Phil. I mean, I suppose if you saw evidence that the anchors were failing or something, then maybe you'd want to do some forensic investigation. But you'd have to see evidence of that failure first.
Gotcha. Okay.
Tony, I think
Right.
we're going to have to put you back on mute because it's very difficult to hear what you're saying given your background situation. But that said, any other questions?
Hi, this
Uh,
is Anna from Hutchinson Architects. Thank you so much for the presentation. Um, is there, I mean, I'm very excited about this project or this product because I see how it could really be applied on some of the NYCHA projects we're working on. And I was wondering if in the process of figuring out sort of the financing or the turnkey feasibility report you would provide, if there's any analysis on the cost savings you would reap from doing an overcladding option versus doing interior furring kind of option, and if there's any sort of basically metrics or analysis that you're able to do to basically for case making for a client why they would want to pursue doing an overcladding and potentially miss out on some of the historic tax credits that are available if you do interior furring.
So thank you, Anna. I think that's a really great question. Hydronic Shell has not done that analysis. It's likely to be a part of the work we're going to do as we get more into the cost analysis for this specific project. My experience, even though I don't have specific numbers to the cost, is that just talking in general about overclad versus interior cladding, even besides the cost difference, there's differences in performance. You end up with much more thermal bridging when you do an interior cladding. It's obviously much more invasive. So really one of the whole reasons for this whole idea is to make it as non-invasive as possible. And as soon as you go do interior insulation, obviously that's a much more invasive process. And then there's also the issue of losing square footage in the space, which has serious implications, sometimes code implications with space getting too small in some instances. So anyway, the answer to your question is we haven't done the specific cost analysis for one versus the other yet, but it is, I agree, an important analysis to do. I don't know if Tony has looked at that kind of cost analysis, but I'm afraid to ask him to chime in.
It's an important analysis to do, but we haven't done it yet.
Hi, this is Freddie Boateng,
Great.
Retech Advisors. Just wanted to ask if we wanted to reach out and potentially get at least talk to you to see how feasible this might be for our property. Do we just reach out to you by that email? Is there a preferred method?
Yeah, thank you, Freddie. That email is fine. You could reach out to me, and myself and Tony will be back in touch with you. We always say, the first step is always just to do that initial feasibility. Some projects are a good fit, some aren't. So just doing a very initial feasibility. Honestly, even looking at a view of the building, from Google Earth can give a pretty good understanding whether or not it's a good fit or not, at least, an initial sense. So yeah, would love to hear from you, and we can check out your building and see if it's worth looking deeper into.
Great. Thank you so much. We're at time at this point. If anyone has further questions for David, you have his email address here on this final slide. It's also in the invite that we sent out along with Hydronic Shell's website. We encourage you to be in touch with the team if you're interested in pursuing this further or exploring its feasibility. With that, we thank you very much for attending this first manufacturer showcase that Empire Building Challenge is put on. Please join us for our other sessions as well. This has been recorded, and the recording will be available upon request. You can just email me, Saul Brown, and we will also be sending out the slide deck to attendees. So with that, thank you very much.
Thank you.
Thanks, everyone.